So the first problem says the population of India was 1.22 billion in 2013 and growing at a rate of 1.28 people per year. So this number here is our initial value, or our P naught. And then this growth rate is the rate that we're going to use. And so we know that we have this model, P equals P naught times 1 plus our rate to the T. So our population is going to be 1.22 times 1 plus 0.0128 to the T. Or in other words, P equals 1.22 times 1.0128 to the T. Then part B says that if the growth rate stays constant, predict the population in the year 2020. So one thing you might notice is that T stands for the years since 2013. And so in the year 2020, that would be when T equals 7. So I want to find the population after 7 years. So I'll plug in 7 for T. 1.22, 1.0128 to the 7. And when I do that, I get so it says round to 2 decimals, so 1.33 billion people. Okay. Find the average rate of change of India's population from 2013 to 2014. So the average rate of change is going to be change in population over change in time. And notice that in 2013, that's when T equals 0, and in 2014, that's when T equals 1. And so when I compute the change in population, I want to find the population when T is 1 minus the population when T is 0 divided by 1 minus 0. And so to compute the population when T is 0, I'll take 1.22 and multiply by 1.0128 to the first power. And I get 1, so I need 4 decimal places. So let's do 1.235616 minus the population in 2013 I know is 1.22. I was given that. Over 1 minus 0 is just 1. And so if I compute that, I get 0.0156 if I round to 4 decimal places. So that's my answer. And what are the units of that? Well, I know population was in billion people, and time was in years. So the rates of this will be the units of the top per units of the bottom. So this will be billion people per year. Okay. Number 2 says polluted waters pass through filters. Each filter removes 85%. And initially, the untreated water contains 420 parts per million of impurities. So the filter is removing 85% of the remaining impurities. So in other words, the rate, R, is equal to negative 0.8. Whoops. Let's see here, I'll get a good eraser here. Okay, let's try that again. 85. So it's removing 85%, or in other words, you could think of it as 15% is staying. So if I write down my L equals L naught times 1 plus the rate to the N, number of filters. So L equals the original level of impurities was 420. And then I have 1 plus my rate, which is 1 minus 0.85 to the N. So L equal 420 and then that's 0.15 to the n. So one filter removes quite a bit. Okay, there. So then what is the level of impurities after passing through 2 filters? So I just need to find the level when n is 2. So if I plug in 2 for n, I get 420 times 0.15 squared. And so let's see that. 420 times 0.15 squared. So I get 9.45. So L of 2 equals 9.45. And what are the units of that? Well, L is measured in parts per million. So parts per million. Okay. And the next one, let's see, I'll do A in blue here. So it says the formula for the price of a gallon of gas, T days, in T days if the price is $2.50 at day 0. Okay, and it's increasing by 3 cents per day. So the price P is going to be equal to, well, I'm going to start out at that $2.50 as my initial value, plus I want to do 3 cents times the number of days, T. And I can see that that is going to work because with each additional day, I'm going to be adding 3 cents. And the next one I'll do in green so we can keep them separate. I'll have it's decreasing by 7% per day. So I'll have P is equal to, again, I'll start out with a 250, but I'll be subtracting 7 cents times the number of days. So both of those are linear functions. For the next one, I'll do in red. I want it to be increasing by 2% per day. So since it's a percent increase, I know this is exponential. Okay, and so my price is going to be equal to, my initial value is 250, but then I'm going to be multiplying by a percent. So if it's increasing by 2%, that's 1 plus 0.02 to the t. Or in other words, I can write P equals 250 times 1.02 to the t. In other words, 102% is what we're multiplying by each time. Okay, and the last one, D, I'll do in yellow. Decreasing by 4% per day. And again, since this is a percent that we're changing, this is exponential. Okay, and so we'll have P is equal to, again, my initial value is 250, but my rate here is going to be a negative 4%. So we'll have 1 minus 0.04 to the t, or if I wanted to write that all together, I could say P equals 250, and then I can have 0.96 to the t. And again, since we see that number that that is the base of our exponent is less than 1, I know that's going to be a decreasing function. Okay, last one. This says the table shows values for a linear and exponential function. We have to determine which one is linear and which is exponential. And so I think the thing to think about is that for a linear function, we have we have a constant rate of change. So if we do the change in the function value over change in x for each of these sets of intervals, we should get the same number. So let's check out what's happening with the function f. And so let me erase some of this previous work so that we can spend some time there. So we're going to compute the average rate of change of f. Okay, and so if I do f of 5 minus f of 2 over 5 minus 2, that gives me what? Well, f of 5 is 2, f of 2 is 1.25 over, and 5 minus 2 is 3. So if I do 2 minus 1.25 divided by, and then divide that by 3, I get 0.25. Okay, let's check. So that's the first interval. Let's check from 5 to 8. So if I do f of 8 minus f of 5 and divide that by 8 minus 5, whoops, that's supposed to be a 5. It's kind of a crazy looking 5. So, I get, so let's see, what is f of 8? F of 8 is 3.2 minus 2 over 8 minus 5 is 3. So 3.2 minus 2 divided by 3. And I got 0.4 there. So what I'm noticing is that my rates of change are not the same. So that tells me that f is not linear. Okay, and so maybe g is linear. So let's check to see if g is linear. So let's compute rates of change for g of x. Okay, so we'll start with g of 5 minus g of 2 over 5 minus 2. So if I do g of 5, that's 1.85 minus 1.25, and I can divide that by 3. Divide that by 3, and I got 0.2. And how about g of 8 minus g of 5 over 8 minus 5? So g of 8 is 3.2. Oh, shoot. G of 8 is 2.45. And g of 5 is 1.85. And I would divide that by 3. 2.45 minus 1.5 divided by 3. And again, I get 0.2. So this is looking promising. I just have one more interval to check just to make sure. If the interval from 8 to 11 also has the same rate of change, then I know I have found the linear one. So let's see. I'm pretty sure this is going to work. G of 11 minus G of 8 over 11 minus 8. So let's see. G of 11 is 3.05 minus 2.45 over, and 11 minus 8 is 3. So 3.05 minus 2.45. That's 0.6. Divide by 3, I get 0.2 again. So yay. All right, so I have found that g is linear. So g of x is linear. Yay. And so what I'm going to do is, for part B, I'm going to find a formula to represent the function g. So I know that for g, my rate of change is 0.2. I already found that. What I don't know is my intercept. So there are a couple of ways I could do this. I could do point slope form, in which case I could do like a y minus y1 equals m times x minus x1. And I can pick a point, maybe the point 2 and 1.25 as my x1, y1, and plug those in. So if I do y minus y1, which is 1.25, equals m, which is 0.2, and then x minus x1, which is 2. I can plug that in, and I'll get y equals, if I want to write it in slope-intercept form, I'll get 0.2x minus 0.2 times 2, which is 0.4, and then plus 1.25. So if I do 1.25 minus 0.4, I get 0.85. So y equals 0.2x plus 0.85. And maybe I shouldn't have called that y. I want to call that g of x. So that's my formula for g of x is 0.2x plus 0.85. All right. So now we might think maybe f is exponential. So let's talk about how we would check. So for our function f, I'm going to erase all the work we did to figure out that g was linear. And we'll start over. Okay, let's talk about the function f. Maybe I'll use a different color here. Okay, so for f, let me erase all this too. Okay, how do we determine if a function is exponential? So to determine if a function is exponential, what we needed to look for is a constant percentage change. Okay, and so what I want to do is I'm going to divide. So one thing I will notice here is that each of my intervals is a constant width. My x values always vary by 3. So since I have these constant fixed width intervals, I can just go ahead and divide. If I do 2 divided by 1.25, what do I get? I get 1.6. And if I do, I'm doing these function values divided by that one. So if I do 3.2 divided by 2, I get 1.6. And then if I do 5.2 divided by 3.2, I also get 1.6. Well, I get 5.12. Yeah, that's why. 5.12 divided by 3.6. Oh, dear. Now what have I done here? 5.12 divided by 3.2. There we go. Then I get 1.6. Okay. And so since I see that for fixed changes in x, I have a fixed percentage change. And so I know this is exponential. Okay, and so how do I determine what the function is that goes with this? So let's go over here and we'll figure it out. So I know that, let's delete all this too. All right, so I know that when I think about this table, that to get from this value to that value, I'm going to be multiplying by b 3 times. In other words, so if I had x, f of x, and if I had like 0, 1, 2, 3, 4, 5, in other words, I know the value at 2 is 1.25, and I know the value at 5 is 2. And I know that to get from one value to the next, I multiply by b. And so in other words, to get here, I'm going to multiply by b 1, 2, 3 times. So times b times b times b. So in other words, to get from 1.25 to 2, I'm going to multiply by b cubed. So 2 should be equal to 1.25 times b cubed. So in other words, to get from 1.25 to 2, I need to multiply by b 3 times. And so I can divide that out. 2 divided by 1.25 is equal to b cubed, and then I can take the cube root of that. So b is going to be equal to 2 over 1.25 to the 1/3 power. And so I get b is equal to 1.1696. Okay, and so then to get my 0th term, I could divide by b twice is one way to think of it. Or another way to think of it is I can just call this a, for instance, and I can say y equals a times b to the x. And then I can just plug in an xy pair. So I can say, so I'll use this xy pair. 1.25 equals a times 1.169 squared, and then I can divide by 1.169 squared. So 1.25 divided by and so I got a is equal to 0.9137. So my function then is f of x equals 0.9137 times 1.1696 to the x.